All right, I think we're going to get started. Thank you everyone for joining us today. My name is Steve Pressman. I'm the president and CTO of Alpine Cyber Solutions. Not the furthest to travel today, but we are from the Philadelphia area, not natively Richmond folk, but we're enjoying our time here for sure. Today, you're going to get a crash course in something that I think if you were in the keynote this morning, really played a front and center position, which is DevSecOps. And it was great. The presenter this morning was almost like I paid her to bring up some of these topics, because now I get to explain to you what she was talking about. If you're not natively a development-focused person, some of those concepts might have been a little bit different. This is a 101 level course, so it's intended to introduce a lot of topics. Please ask questions when we get to that point. And if you have questions in the middle and I'm going far astray from something that you understand, that's fine too. I can speed up and slow down as we need to. So with that, let's get rolling. First, a little bit about me. I spent the first 10 years of my career with Lockheed Martin. I come from the systems administration side of the house, and I do have quite a bit of experience on the DevOps side. And I found that a lot of security people, as well as a lot of DevOps people, you either come from the development side or you come from the infrastructure side, and you bring these perspectives with you throughout your entire career, and you learn the rest, and sometimes you develop new affinities, but in the end, you still have your core of where you came from. So I am and will always be an infrastructure first guy, but I do respect the entire spectrum of both DevOps and information security, because you really have to if you're going to be a decent technologist or security person. I spent a couple of years after the SI working in one of their spin-off companies. I won't go into the details of why, but I did get to spin up their infrastructure for the SI organization as their solutions architect. It was my first real jump in my career. And since then, a business partner and I decided to go and take our show on the road and bring those defense grade things that we had learned down to the small and medium sized businesses. So we started Alpine Cyber Solutions 11 and a little bit more years ago. And I spent a lot of that time working in the DevOps field. And I slowly but surely started to realize that because of my brain and my proclivities, I really was bringing DevSecOps to these companies as I went. And that's where a lot of the things that you're going to learn today, you're going to see today, came from. Certifications, if you were here a little bit ago, I was talking about how they don't really mean anything, but they fill up a nice block of space on the chart, so I had to make sure I put them there. I do have a love of AWS. I have a necessity of Azure and a love of AWS. It's just how I am. But I understand that they do this, some of the similar things if differently. And it tinges my worldview to be a cloud-first security person. And that used to get me raised eyebrows, but I think people in this room will understand that that is not a weird thing anymore. So, I'm a Disney guy too. Sorry, if you're not. In this class, we're going to go with class. Listen to me. In this session, we will talk through a few real basic things. We're going to talk about DevOps in general, because I think if you are like most people in the world, you may have some different understandings or beliefs as to what DevOps actually is. And then we're going to talk through the different phases of the application pipeline, application lifecycle, to talk about the different ways that you can secure it and imbue security into everything you do as a DevOps engineer. And then finally, we're going to talk about the super fun stuff, the GRC, the governance section, and how you develop a DevSecOps program as an information security officer. I'll try to go through it quickly so that you don't have a chance to fall asleep. No, it is very important in how you declare your standards, and we'll get through what those different standards might possibly be as you build your DevSecOps program. Let's start with the application lifecycle itself. There's a lot of different ways to talk about the application lifecycle, and I think if you've been in this industry for any period of time, you've probably seen a few different paradigms. The systems engineering in COSI says that you've got this super linear with a dip in the middle. Left is the development, right is the operations, and it's the old straight line. Iteration is not a thing. This is the way we used to think about computer systems, and it's the way a lot of companies still do. You start with your requirements, you move through developing a concept of operations and a design, and then you start coding and you develop it, you test it, make sure you hit your requirements, and then move along. And when it's done, you go and find your next project, because operations is somebody else's job. That's not the way we look at it very much anymore. That is essentially the way the waterfall model was, and likely still is if you're in some industries, but thankfully we've discovered that iteration makes more sense, and the merge of development in operations into a single flow makes a lot more sense. And when you're done with one iteration, you move into the next iteration, and that's how an application is born and maintained. But it's way more than coding. A lot of people that I talk to are perhaps not code people. They're not application people. Perhaps they live in the infrastructure. They don't understand that you don't start an application by bringing up your IDE and typing code. Now, maybe if you're building a script or something like that, but if you're building an application, you really have a lot of stuff to pay attention to before you even start typing any code or going to ChatGPT if you're any good at that. Which, if you're not, do it. So now we're going to talk about DevOps, because DevOps, oh yeah, my big warning. DevOps is not a standardized term, okay? And neither is DevSecOps, spoiler alert. We're going to talk about things the way I've seen them in the industry. We're going to talk about things the way I believe they are, but we're also going to branch off a little bit to talk about how it perhaps could be. But depending on who you ask, it could be very different. Now, as a core, DevOps itself is the merge of development and operations. It's supposed to be the idea that you no longer are thinking like an infrastructure person or thinking like a developer. Everybody is espousing overlapping and similar mindsets. You're merging the world of requirements, coding, deployment, operations, lather, rinse, repeat. A DevOps person, a DevOps organization, is going to believe in collaborating. Collaborating is the most important thing. If you came from a world where it was not a DevOps mindset, you were going to be in a place where the developers, when something goes wrong, either ask for access to production so they can go in and fix it, or they blame the operations people for screwing it up in the first place, who then go and blame DNS or the database. That's how you do it. That's what running an application meant. This DevOps concept is intended to bring those organizations, those people together, so that you don't end up in a situation where you're just pointing fingers. You're actually solving problems and iterating over them and solving them quickly. Which brings us to automation, because the DevOps people in the world are scripters. You're writing infrastructure as code, which is further down the list. You are automating processes so that when you do something again, it's not bespoke and handcrafted. You're just executing that script that you did the last time you did it. So you don't end up with your various environments looking different from one another because, I don't know, maybe you capitalized the name of the environment in one, and then the next time you run it, you didn't, and you're on a Linux environment, and now it doesn't work. That's the kind of stuff that we do with automation, and that's a tenet of DevOps in my world. Continuous integration and continuous deployment, CI/CD. When you're writing your code, you're not waiting until it's done before you test it. You're continuously integrating your code with the code that's written by other people. You're continuously deploying it to an integration test environment so that you can know quickly, fail fast. You can make the fixes that you need to make before they get too far. Cloudification is another piece of this, and that's really opportunistic. All right, obviously in the last 10, 20 years, we've seen cloud become a dominant force. It just so happens that one of the aspects that makes a cloud is a good API, and you can script against it, and you can automate to it. I'm not saying you can't do that now to the on-prem, but if you remember VMware 3, like I do, you were clicking through a GUI, and you could not really automate anything. So cloudification gave us the opportunity to make that infrastructure something that you can deploy with your code, and you can version it with your code. And the DevOps world is now born out of that. The piece that people forget about sometimes, unless you're actually a site reliability engineer or a DevOps professional, is the monitor and logging. Monitoring and logging to know if your production issues if your production is having an issue or not is very important in order to feed back into the process to bring new requirements in. This is what makes it an infinity symbol instead of just a V, right? It's feeding back from your production environment into requirements then for your developers to fix. And this is all because of your DevOps people. And we continuously improve ourselves. We have retrospectives. We check to make sure that we're moving fast enough, we're efficient enough in what we do. This is what makes DevOps DevOps. It goes by a lot of different names. Okay, site reliability engineering is a Google term that has become more and more valuable. Platform engineering, agile operations, even organizations calling themselves continuous delivery are DevOps organizations. Biz DevOps is something that I had never heard of, but when I was doing some research for these slides, it's out there and people are doing it, and it really is trying to bring in business requirements into the DevOps field. So you're really going cradle to grave on an application covering the entire organization. FinOps is a slightly different one. That one is where you're really focusing on the cost optimization. Oops, look at that, it's advancing on me. Your FinOps is a collaboration between your finance organization and your business and your DevOps, which is focusing on how do we run this application cheaper, which is pretty cool. If you know anything about cloud, you know that there's a lot of ways to spend a lot of money. This is trying to make it so that you pick one of those ones that doesn't spend a lot of money. So, if you look at the same sort of infinity logo here for the application lifecycle and you map onto it that's going to get annoying. You map onto it what some of the different pieces are that a DevOps person pays attention to. You can see that there's a lot of moving parts. And at each one of these transitions between operating, monitoring, planning, coding, building, testing, releasing, deploying, there's an opportunity and almost a requirement for security. And that's where we come in, because we're going to talk about why, but you absolutely need to be focusing on security at each of those pieces. Why do we DevOps? I'm not going to go into this too deeply, but the fact of the matter is, by streamlining your development process, you are getting faster to market. You're deploying things more quickly, which makes the security people a little bit more nervous because you don't get all the time that you might have had to do a long assessment of an application. You've got to do it as it goes, as the requirements are being met, as the code is being written, as the requirements are being written. Theoretically, you have better quality and reliability because you're going to fail fast, as I mentioned. You're going to find a lot of bugs before they get to production, and you're going to find them when they occur in production quickly and get them fed back into your development team to go and get them fixed. Scalability, resilience, now we're just echoing what the cloud brings to the table if you architect it properly, as well as cost savings and the continuous feedback. Perfect world, right? Well, as I mentioned, just because you go fast and just because you deliver a lot of features doesn't mean that you're doing it well and doing it securely. Hence, DevSecOps. So, bringing back to our infinity, the various segments, and they're numbered because that's how you traditionally start, right? Plan, code, build, test. But again, it is a continuum and things feed back into one another. At each of these locations, this is the sort of concepts of things that you can be doing and should be doing as you get to each of these portions. And I'm going to take you through each one to show you some of the technologies and concepts that you can see in the field. So, why do we do it? Why do we want to do this? The biggest thing, and if you take away one thing from this, if you need to sell DevSecOps to your organization, it is this chart. And in fact, you're going to see it again later. I'm going to bring it up twice. The earlier in a code development cycle that you can find a bug or a security vulnerability, the cheaper it is to fix. Dang, I told you this thing's going to make me mad. If you find a bug or something that's a security vulnerability or a potential security vulnerability while you're defining requirements for an application, okay, we fixed that requirement. We haven't done any work to write the code. We haven't done anything to deploy the code, and we definitely haven't exposed any of our customers' data to that bad decision that was made months ago in the planning phase. So if we can find our bugs, find our vulnerabilities earlier in a cycle, you're going to markedly save money. If you wait until you're in production, that's when you have things like data breaches. That's when you have things like reporting to the SEC because you lost people's personally identifiable information. If it doesn't get to production, you don't have to worry about that. It gets cheaper and cheaper as you go back. Okay, big disclaimer. I'm about to bring up a lot of concepts. I'm about to bring up a lot of products, and I don't work for any of those. I'm giving you examples. I strongly recommend that you do your own research if you're implementing DevSecOps in your organization, because you might be using a different language. You might have different skill sets within your development team that are going to really need more or less focus in different areas. So I recommend you take this with a grain of salt, and definitely just take it as a guide. Okay. The planning phase. This is the earliest part of the application, and the best thing you can do while you are gathering requirements and building your initial product designs is threat modeling. Threat modeling is a structured practice where you analyze your application design and you try to figure out what might go wrong. You try to figure out conceptually where, when data goes from one trust zone to another trust zone, you might have an injection of bad guy actions. A good one, a good threat model, will leverage the MITRE ATT&CK framework. If you're not familiar with the MITRE ATT&CK framework, I strongly recommend you do a little reading on it. It is a great database of tactics that the bad guys use in the real world. And when you're doing a threat model, you're taking your design artifacts, your pictures, your graphics, and you are looking for places where the application data is moving from perhaps trusted zone to an untrusted zone, or from component to component. Maybe you have a web front end and a database back end and maybe an API in the middle. Okay? Each time something goes from one of those concepts to another, there's an opportunity for a bad guy to do something bad and perhaps get access to that data. And what you need to do in a threat model is go through the thought exercise of figuring out what those things might be and where they might get you. You're not exposing vulnerabilities here. You're exposing threats. You're focusing on what the bad guy could do. There's nothing that's been written if you've done it early, if you do it in the requirements phase. By the way, you can do a threat model after it's already deployed to production too. Don't let the fact that you've already started writing code stop you. Go back and do the threat model anyway. It's a great exercise and it's a great artifact to have. The output from this is usually a very well annotated picture of your application components and arrows that tell how the data moves between your application components, and a list of things that you need to watch out for. It's not to say don't have an application web front end and an API and a back end, but it does say make sure you encrypt the data between those. Make sure you authenticate at each of those levels. Make sure you take the proper steps. There are many different methodologies. If you Google threat modeling, you're going to find Stride is a pretty popular one. Microsoft actually has a free tool that you can use for it. If you, like me, question anything that has the word Microsoft in it, don't be afraid to go to one of the other models. It's fine. All right, these are just methodologies in different languages. If your organization loves Visio, then you're probably going to get pushed into a Stride methodology, which is okay. It's fine. The Microsoft threat modeling tool is very helpful if you're doing Stride, but there are also some open source ones, right? So the OWASP Threat Dragon is a cool thing. Basically what it does is it gives you the picture, so you still have the architecture diagram of your application, but it also is a database of your potential threats that you could work off as a list to say, all right, I addressed. All right, so that's a good way for you to keep an eye on the whole picture, but also on those threats themselves. Threat Modeler is another free one. And then if you just want a picture and a spreadsheet, that works too. Draw a picture in Visio, Lucidchart, Draw.io, that's fine. Have a picture. Don't just start writing stuff, all right? And then analyze it. All right, in the coding, you've started writing, and what do? So there's a lot that you can do. And by the way, I don't think I was clear on this. You don't need to do every single bit of this. Every organization is going to have different priorities, different budgets. A lot of the things that I'm going to bring up here cost money. That's not to say that you don't do them because they cost money, but you have to do the cost-benefit analysis for your organization. And your business needs to say, I can't afford to lose data out of this application because it's driving too much revenue. I'm going to spend some money on a platform that's going to bring me some of these capabilities in the securing of my code of my applications. So an IDE plugin is great. Linting. For those of you who aren't developer-minded people, linting is essentially applying patterns to make sure that when your code is written, it's written the same. We use 2 spaces to indent as opposed to a tab. If you watch Silicon Valley, you know what I mean. Okay? If you capitalize the first letter of your functions, it's going to make sure that you're consistent. You're following a consistency across your development team so you don't end up with a mixed mishmash mess when it all integrates together in your source code repository. But also more. All right, you can have it so in your IDE, it's doing real-time scanning of your code to check for static code knowable bugs. You do have to be aware. You will likely annoy your developers. If there's any developers in the room, I apologize for what I'm about to say, but developers are fragile. You don't want to piss them off too much. All right, and you kind of get it in some respect. They're the ones who are putting the rubber on the road for your application to make money for your company. They want administrative rights to their machine. They want to be able to do whatever. They want to go out to the cloud and spin up their own infrastructure and do their own development how they want to do it, and they don't want to follow any patterns. And I'm overgeneralizing, but I've met a lot of developers. So you have to make sure that as you imbue these things into your process, that you mind your culture. And I believe that this morning the keynote speaker brought up the fact that getting this to be something that your development team wants to do is the magic. It is the magic. If it can come from an architect or a senior developer that, oh yeah, this thing made me a better developer, that's going to be better than security coming in and saying thou shalt and you must. All right, so the culture of your security team really needs to be something that you keep an eye on, otherwise you will get backlash. And while you'll be morally correct, that doesn't matter when your morale is in the crapper. So your IDE plugins are usually language dependent. Figure out what works in your environment. Pre-commit hooks. A pre-commit hook is a scan, a static scan of your code before it gets to your source code repository. We're going to talk in a minute about static scanning that's going to happen after code is in your repository. But if you can get that fixed before it gets into your repository, there's less churn, less things that need to be done by other people to check to make sure that your code isn't bad. All right, so your pre-commit hooks are going to be important. I don't like dealing in too many absolutes. Most, if not all, modern source code repos support actions before commits. So pre-commit hooks are something that you can do no matter what. If you're using GitHub, you're using Azure DevOps, and I sound really echoey suddenly. Does that sound bad? All right, okay. Yeah, if you're using Bitbucket or you're using GitLab, whatever, you're going to be able to do pre-commit hooks. So definitely get those into your process. Now, after the code is written, it needs to be built. It needs to be compiled. It needs to be made ready. We are really zooming here. Sorry. This PowerPoint, I don't like PowerPoint. Microsoft, right? Anyway, the static code analysis happens at your build phase. All right, so this is where you run tools against your code as it sits in the repository, and as it's being compiled, it's being applied, patterns are being applied to it to say, hey, if you deploy this like this, you probably are going to have a cross-site scripting problem. Or you're going to hey, we discovered that you have a password embedded in your code. That's a no-no, you shouldn't be doing that. Hey, you're reusing a function that has not good enough randomness in its random generator. Okay, there's going to be all kinds of things, and be ready for the developers to say, oh, that doesn't matter. That's fine. It's a risk analysis that you have to do, but you won't know it unless you run static code analysis. All right, most orgs don't do static code analysis until this phase. If you don't do it in a pre-commit hook, that's okay. Do it here, because this is the easy stuff. All right. Oh, you'll also, if you do it right, you'll also get some good quality, some good code quality and test coverage statistics as well. So you can kind of really hold up a mirror to your developers to say, you have to fix your development process, fix your standards a bit as well. The tools that you can use here are many, okay? If your source code repository has one, maybe you use it. Now, I know in the conversation this morning, the keynote speech, there was a talk about that upcharge that happens when you implement these things in your code. If you can swing it, it's worth it. Is it a problem in the industry? Yeah, it's expensive, but that doesn't make it less important that you run static code scans against your code. So if you have to pay more to use GitHub Advanced Security, or GitLab has it built in, Azure DevOps has it built in, you can do this with all of these. You have to make the decision, is that worth the money? And that is not a security team decision. That is not an IT team decision. That's a business decision. The business has to be the one to say, spend the money to drive down the risk. They own it, not you. If you can't swing it, and she even said it this morning, it was great. SonarQube is an open source free static code analysis tool. You can spin it up in a Docker container, and the instructions are all out there. There's a community edition that is absolutely free. Is it the best thing? Is it the greatest user experience? Of course not. But it's better than not doing it, and it's better than using the excuse that you couldn't afford it. Now, just like with anything open source, anything that you don't buy out of the box, you've got to run it yourself. You've got to spin it up. You've got to manage it. You've got to patch it. You've got to use it. So do it. All right? It's better than not. There are a lot of commercial products out there. Sneak, Veracode, Checkmarks, Data Theorem, and I just pulled those out of my head because we've recently written an RFP for a company that we were going to be doing static code analysis for. So there are a lot of vendors out there. As long as you do it, that's what matters. What else do you need to do? So, all right, SCA. SCA is not software code analysis, which is what a lot of, when you look at it, that's what it feels like it should be. It's actually software composition analysis. Static application security testing, SAST, and then software composition analysis, SCA. SCA might be the most important thing that you can do outside of static code analysis, because every developer is using third-party tools, third-party libraries. Okay, what software composition analysis does is it looks through your code that you didn't write but you are depending upon. So all of your third-party libraries, it looks for known vulnerabilities in those. Remember Log4j? That was big. And so many applications used it, even those commercial products you spent a ton of money on. Guess what? They didn't spend any money on Log4j. They brought in an open source library, and that's what they were using to log in their code. What a software composition analysis scam will do is let you know, hey, you need to update this dependency, or you need to avoid this dependency because there's no patch for this big vulnerability that exists within it. And maybe your developers are going to have to go write more code. Okay? There are a lot of solutions here as well. Black Duck, Dependency Check, Dependency Track, some free, some money. I will say, pretty much all the tools I named on the last slide also do software composition analysis. A lot of these vendors are getting wise to the fact that if they bundle all this stuff together, they can charge you more money, and you'll get all of these capabilities at the same time. So you either can bristle at it and try to implement it all in open source, or you can just steer into the skid, pay the price, and you'll have a good solution that will cover you for all the things. Not my decision to make for you. Testing. So now you've got a built product. It exists. It's in your UAT environment. You've got people hitting it to make sure that it functions. What about, is it secure? So all we've done so far is we've scanned your code as it lives in your repository. It's static. It's not running anywhere. Dynamic application security testing is deploying your software and then testing it so that you can see what vulnerabilities might be added now that you've moved it into an environment where it's hosted. Because that might not have anything to do with your application code, but maybe your infrastructure code is really wonky. Or maybe you have something you missed in a threat model that you did way back, and you now realize, oops, I forgot to encrypt my front end. Okay? So a dynamic application security test will programmatically spin it up and test it as though it's real and actually running. Boop. It is absolutely related to pen testing. It is just like a pen test, except fully automated. And that, I'm going to go forward and then go back. Tangent. I'm going to go on a quick tangent. Artificial intelligence and software-based pen testing cannot replace a human-executed pen test. When I start talking about penetration tests in a second, I am not talking about another fancy vulnerability scan. AI tools may someday be able to replace a good pen tester, but not yet. At this point, an AI-based penetration testing tool is a misnomer. It is just a really, really good and advanced vulnerability scanner that can help a pen tester do more, but will not replace a human. Please don't fall for the trap. It's all marketing right now, okay? And my last note, at least not yet. We might come back RVAsec 14 and say the exact opposite, but we're just not there. So just going back real quick, for dynamic application security testing, Acunetics is good for web apps if it's a web application. Burp Suite is a great tool if you're a pen tester. You already know about Burp Suite, but it also does have some automated dynamic tools, processes it can run. Invicti is another strong in the Gartner quadrant for dynamic testing. And as I mentioned, pretty much everything I've said before, because they all are a suite that they add to. Okay, now that you've tested, we passed our tests, we're ready to release and deploy. I hope this thing doesn't automatically flip. We'll see how it goes. When you're deployed, when you're releasing and deploying your code, there are still things that you can do. When something first gets out there, normally if you're in a development environment, you're going to do what's called a smoke test, just to make sure things are working-ish. Usually the people who are doing the deployments don't have the ability to do a full end-to-end test to make sure everything is working perfectly. You're in production now. You're in the real world now. But there are some things a good security person can do. Chaos engineering is so cool. It's just really cool. Chaos engineering is the concept that let's see what might happen. And there's a tool, Chaos Monkey I have listed there. That was a Netflix developed tool for when they first moved to AWS. And essentially what it does is it randomly destroys servers and destroys load balancers and invalidates configurations. And it says, okay, Netflix application in production, let's see how you do with this and see how it automatically or how their management team recovers from it. This is truly like disaster recovery testing in production. Very cool stuff. I've never come across a real world scenario where people do that because that's expensive, right? And you don't want to cause it to go down, but it's cool. IAST is interactive application security testing. This is the last of the ASTs, I promise. So we had static, we have dynamic, now we have interactive. This is testing in production. This is synthetic transactions moving through your production environment to make sure that it's working as it should. This is checking by running something into your production database, is it secure? All right, it is still automated, and it is still checking for security problems, but it's doing it while your customers are running alongside it as well. Very advanced, very cool if you can get there, very difficult, because your code has to make sure that you're able to ignore those transactions. If you're doing a payment application, you don't want it to actually take money out of someone's bank account. You have to make sure that the application is orchestrated for that. Vulnerability scanning of things like your container registry. This is where you would do that. If you are a containerized application, your code gets deployed into a container registry. Well, you might have had no problems in that today, but tomorrow a new vulnerability is released. You need to be scanning your registries to make sure you don't have any latent bugs, latent vulnerabilities in there that you need to address. So this is where you're doing your vuln scanning. And vuln scan your actual environment too, right? You need to be checking to make sure you don't have any issues in that environment that can be discovered, because if you can discover it, the attackers can discover it and get into it. Pen test, get a human. PAM and IAM, you need to make sure that you're keeping an eye on your privileged access management and your identity and access management, because identity is the new security border. You need to do what you can in your application to make sure your authentication is doing its job and your authorization is doing its job to make sure that only the right people are getting in. I had one more. Code signing. Code signing is old, tried and true. That is the process of making sure that your code as you deployed it is still the code that's running in production and hasn't been tampered with. More important when you're delivering an application to a customer that they run on their environment. Less important in a web application because you control the whole thing. If you've got tampered code, that's going to be a problem beyond what you have deployed, right? You've got another problem. Somebody's tampering with your code in your environment. But important to do. And then finally, monitoring. The monitoring of your application, this is where you need to do your traditional. This is where a lot of us live, right? This is infrastructure security. This is having an MDR system, having a SIEM. Maybe I'm on the fence about whether there's value in a really expensive SIEM anymore. I think a good MDR is just as good, if not better. Your SecOps team, they're going to be looking to make sure there's no signs of intrusion. From an architecture standpoint, having a WAF, right? Having a RASP. RASP is a cool acronym. I usually think of these as APM, application performance monitoring. But a runtime, this is basically an application that allows you to see code moving through your application. So you know this customer had this experience and this amount of time between this call to that call. Very cool stuff. App Dynamics is the one that I used to use when I was working at Wawa. There is a lot of opportunity there to look for security problems as well. And then finally, vuln scanning of your operational infrastructure happens here. Okay, and then finally, response. When you're at the point in your application lifecycle that you're in the response section, you've got this thing running, you're monitoring, you're responding. If you find a bug now, welcome to the most expensive bug you can find. Okay, this means that this has gotten all the way through all of your tests and the bad guys are doing bad things in your application. You can do a lot of things to help avoid this, right? This is where bug bounties come in. You want to make sure that you can roll back a version of code that perhaps has a new bug in it. So if you do a blue-green deployment, it allows you to flip back to the prior version pretty easily. Feature flags. For those who aren't in the developer space, you can turn on and off different features. I made this new feature, but it's not going live yet. I set it to go live by setting a flag off in the cloud somewhere. Oops, vulnerability in that, I turn it back off. Okay, that's how you can mitigate that sort of stuff. Okay. And then finally, throughout all of this, this needs to integrate well with whatever your vulnerability management program is in your company. Okay, you are generating vulnerabilities, identifying vulnerabilities, and it needs to feed back into your patching, your software development process, right? So I find a bug in production. That needs to become a story in the next sprint or the current sprint for your development team to fix, because if they don't, you're leaving it out there for too long. When I'm doing a third-party risk assessment for one of my customers, if they're evaluating a new vendor, I'm going to say, how do you, don't tell me what your bugs are. You're not going to tell me. They're never going to tell you what their bugs are. I want to know what's your process for prioritizing a found bug in production in your development team. That's what matters to me. Show me your process. Everyone's got bugs. It's a fact of the matter. Yeah, this is a lot. It really is a lot. And like I said earlier, you don't have to do it all, but you have to do some of it. And now we're going to talk quickly about implementing, standardizing, and measuring. So, as I mentioned before, culture change is a huge thing that you need to do. That is the biggest problem. You're going to tell developers that they can't get new features out there fast enough? Well, that's going to piss off a lot of people in the organization. You're going to have project managers who are perhaps getting incentive compensation. They're getting paid more the more features they get out there, and now you're telling them to stop and secure the ones that they've got. That's tough. That's tough. So it helps to have security champions within the team. All right, they need to be advocates for your team. It's funny, I had a conversation last night where security champions were kind of poo-pooed a little bit because they tend to be more skewed towards the application development side, and it's just window dressing. They don't actually do it. All right, what I'm saying is do it well. Make sure your security champions are nurtured, loved, and taught, and continuously engaged. Right? If you have security champions in a large organization, have them be an organization that gets together as a community of practice. Right? They're the ones who are going to be helping you implement. Show value. Be loud when you find a bug in the pipeline. Make sure people know that you've avoided, right, those numbers that you can never really stand behind. Show that this bug that you found is avoiding problems in production. And then money. This is the biggest challenge, is how do you sell this to the people who don't want to spend any money, they just want to reap revenue. I told you I would bring it back, and here it is again. Show this picture to your executives. This will hopefully convince them. Data breaches are expensive. This was from an IBM article from 2 years ago. They did a study, and they found that the second greatest factor in reducing the cost of a data breach was the DevSecOps approach. Because if you don't have the problems, you don't have the breaches. That's the point. All right, so what do we do? I'm going on another tangent. So the CISO's job is to do this, but a lot of the CISOs I've met in my career, do not understand applications. They understand firewalls, they understand SecOps, they understand monitoring, they understand MDR, they understand risk, they understand policy. They don't understand applications. That's not good enough. In today's day and age, if you're an application company, you need to have a CISO who understands, or at least addresses it in some other way by perhaps outsourcing it. So the CISO's role, whether they understand it or not, is to define those implementation models. How do we DevOps? Let them live in their space. Let's talk about the policy for our DevSecOps, our application lifecycle. Declare how we do it, okay? Define how mature we need to be. That's their responsibility to go talk to the COO and the CFO and those who own the risk. Figure out which components you need in order to feel comfortable enough. Like I said, not every requirement needs to be fully implemented to the highest level of maturity. Your CISO is also going to be the one to advocate for budget. If you let the development teams do that, guess what's not going to happen? Okay? You also need to track your compliance. It's boring, I know, but you need to do it. And if you're a CISO, it's part of your day-to-day job. Okay? As I mentioned, a virtual CISO is not an admission of failure. Outsource it if you don't know how to do it. We always like to say, do what you do well and outsource the rest. Okay? And that's fine. Ignorance is not acceptable. All right, I'm going to go quickly through 4 ways to standardize. There are so many standards out there for everything in this world. If you're securing a firewall, you can go to the Center for Internet Security, the CIS, and you download a benchmark, and it tells you how to do it by best practice. The same thing is true in the DevSecOps world. OWASP, for those who don't know, it's the Open Web Application Security, something like that. They're the people who define the standards for securing web applications. All right, they have something called the DevSecOps Verification Standard. We actually have implemented this for one of our customers to great success. It defines a lot of what I told you, fully expanded. And you can decide, I want it, I don't want it, I want it, I don't want it, and here's how mature I want to be. It focuses on controls and measurement across all the different phases of the application lifecycle. That's what you need, okay? And this is one way to measure it. I am not going to show it to you. You can go look it up yourself. OWASP is great because they really espouse a lot of different things and they don't just stick to one. They also have what's called the DevSecOps maturity model. Because not only do you need to have a verification standard, which shows you all the different things that you can do, you need to also measure your maturity. So I do static code analysis. I run a static scan every 3 months. Okay, but you release new code every 15 days. You scan every 3 months. You think that's good enough? Sure, you do it, but your maturity is, okay? So you need to get, sorry. You can espouse something like the DevSecOps maturity model, which gives you different levels. Basic understanding of security practices, I'm adopting them. I have high adoption, I have very high adoption. And it's something that is quantifiable, that you can report up as a CISO to higher levels to show the value, okay? It is strongly recommended that you focus on a maturity model. All right, the DoD, never one to leave the rest of the world to do their own thing. They have a guidebook that talks about the DevSecOps fundamentals. I am so sorry for this. It keeps doing that. It is a very thorough guidebook. If you're looking for some good information, some deep information, I assume these charts are going to be made available, I hope. These links are active. You can go right to it. It has strong echoes of everything that we've talked about here. And as the DoD is wont to do, it tells you what to do. It is very prescriptive. It's very much do this or you're not secure. Okay? Good read, definitely. And again, they don't care about maturity. They're do it or don't. They're very binary in it. You either are implementing these things or you're not. And then finally, NIST, our favorite, is, along with the National Cybersecurity Center of Excellence, has what they call the Software Supply Chain and DevOps Security Practices. Yeah, let's add more. I'm just glad that they didn't decide to make that into an acronym. It is very new. This is a NIST publication that is only recently coming out. And actually, they're actively looking for collaborators. So if you go out to their site and you are passionate about DevSecOps, you can contribute. And actually, a lot of organizations would relish that. They're hoping that it's going to be a lot like the NIST cybersecurity framework. For those who know, very prescriptive. Sorry, Spider-Man. Very prescriptive, just like the CSF. It'll show you how to be. Okay, what's the point? So why all the fuss? Applications can be insecure. And this is, like I said multiple times, where the rubber meets the road. Okay, you're making money with this thing. It's got to be out there on the internet. It's got to be deployed to your people. When you have something like Log4j, Log4Shell, that was a widely exploited vulnerability, if there was DevSecOps, that might not have happened. I can't guarantee. I don't know the nature of what they did wrong, but if perhaps it could have been found in a threat model. NotPetya, for those who remember, this is a huge supply chain attack that took down Merck for a nice hot month, along with a lot of other companies. All right, it was a introduction of malicious code into their code base. Would have been found with software composition analysis, would have been found with static code analysis. Okay, SolarWinds. SolarWinds was huge. If you're in the governmental space, you know what I'm talking about. All right, the SolarWinds bug or vulnerability hit big business in a big way, and every government agency I've worked with, I know also at some point was using SolarWinds as well. And then Ashley Madison, am I right? No. No. Anyway, if you haven't seen the Netflix special, episode 2 is great. There is a lot of reason to do this. And you, if you're in a decision-making role, you need to be advocating for DevSecOps in your application lifecycle. Okay, takeaways. Application security is something that you must do. Silly, simple. All right, it will save you money. DevOps and DevSecOps will save you money if you do it right. Okay, don't pay attention, or don't forget to pay attention to every part of the pipeline. You must deal with the culture change. It's not going to be successful if you don't. Your CISO has to be actively involved. And finally, executive buy-in and visibility is crucial because it costs money. All right, I know that was long. I know it was a little bit dry. I apologize for that. It's not my concept. But I will say, I hope you came away from this with something of value you can take back to your organization. If you do nothing more than static code analysis, that's a start. Go do it. Go download SonarQube. Make it happen. If you can do more, please do more. If you need help, give me a call. Does anybody have any questions? Yeah.
You mentioned earlier about tracking metrics.
Yes.
DevSecOps. What are some metrics that DevSecOps tracks?
So a lot of that is going to depend upon your vulnerability management program as a whole. Again, every one of these things in some way, shape, or form is generating vulnerabilities. So those things that you're tracking already, you could likely do as well. And additionally, a lot of your development environment, your development process is going to drive those standards, right? Your story points, how much your velocity that you're accomplishing things. Because next thing you know, I introduced a security bug. I need to go and fix that in this sprint, and therefore I'm getting less new stuff done. Outside of that, I mean, it depends on how persnickety you want to be. If you're looking in production, number of bugs in a bug bounty program, that's something that would be an interesting KPI to a lot of companies if you've got a lot of bugs for sure. But it really does focus around the vulnerabilities and threats. Anybody else? All right, I'm going to get the hook. So please, thank you. If you have any questions, find me later. I appreciate your time.